All right, so this is my tutorial on the probability of independent events, which is going to be the first of two. We got independent and dependent events, and let's go ahead and get started. And if you read these problems, this is the type of stuff you're going to do eventually. Now, I'm not going to read the whole thing to save time, but here Jack has choices of entrees, sides, and a drink. And if it was random, you can figure out what's the probability of Jack picking a chicken entree, broccoli side, and a tea for a drink. Okay. And then if you have a die, which is a number cube, and you toss two coins, so you got three separate events. If you wanted to figure out the probability of getting a 6 and getting a head on the first coin and a head on the second coin, and that's where we're headed to, figuring out the probability. And these are independent events. First off, definition: independent event is when an occurrence of one event has no effect on the probability of a second event. In other words, what happens first does not affect the second one, like flipping two coins, spinning two separate spinners. Now, we will be doing dependent events later where the first one does affect the second one, but let's not worry about that now. Now, in order to figure out the probability of two or more independent events, well, you got to figure out the probability of each individual event, and then you multiply them. And so this is the formula you're going to see for two events. The probability of A happening and B happening is going to be the probability of A multiplied by the probability of B. And basically, you're just using what we learned before with theoretical and experimental probability. All right, so let's get to your homework. Here we have some examples. And I believe this is the exact homework that I gave you. And so we want to figure out what's the probability of getting a red and a yellow. Now there's different shapes and there's different colors. So if you want to figure out the probability of picking one randomly, well, first of all, what's the probability of getting a red? So let's use red. So how many reds are there? We got 1, 2, 3 reds. Okay. So the probability of getting red is going to be the desired outcome of getting a red, which there are 3 desired outcomes. Oops, make that 4. Oops. Sorry, there are 4. So the desired outcomes are 4. Let me double check that again. And how many total outcomes are there? 12. And you can simplify that to 1/3. Okay. And then let's figure out the probability of getting a yellow. So figure out probability. What's the desired outcome? Yellow. So how many yellows do we have? We got 1 yellow, 2 yellow, and it looks like this. So 2 desired outcomes of yellow. How many total outcomes are there? 12, which is 1/6. So individually, the probability of getting a red is 1 out of 3. Individually, to get the probability of getting a yellow, it's 1 out of 6. And so to figure out the probability of getting one of each on 2 separate picks, you just multiply. What's 1 times 1? 1. 3 times 6, 18. And so the probability of getting a red and a yellow is going to be 1/18. All right, so let's go ahead and move on to the next one. And you can see here that the answer is 1/18. All right, here we go. Next problem. Probability of getting a circle and a blue. All right, so again, these are independent events. And since you are replacing it, I forgot to mention earlier, you're putting it back. So basically the first event does not affect the second one. So let's figure out the probability of getting a circle. Well, what's the desired outcomes of circle? We got 1 circle, 2 circle, 3 circle, 4 circle, 5 circles. So the desired outcomes are 5. Out of how many? Well, it's out of 12. And so we're going to multiply that by the desired outcome of blue. How many desired outcomes of blue are there? We got 1 blue, 2 blue, 3 blue, and that looks like it for the blue. So we got 3 desired outcomes of blue out of how many outcomes? Well, there's 12. And you can simplify that to 1/4, but I'm going to go ahead and just show you how to, you can cross cancel. So 3 goes into 12 4 times. This becomes 1. And then you multiply across. You end up with 5. 1 times 5. And 4 times 12 is 48. And so the probability of getting a circle on the blue is 5 out of 48. Okay. So let's go ahead and move on to the next one. And let's see. There's the answer, which is 5/48. All right, next one, probability getting a purple and a green. Again, these are very important because they're being replaced. That means they're putting back each time. So probability of getting a purple. Well, how many desired outcomes of purple are there? Well, let's see. You got one purple. And that's it. One desired outcome of purple. And again, out of 12. And now let's figure out the green. How many desired outcomes of green are there? Well, let's see. We got one green, two green. Just two green. Out of two desired outcomes of green, out of how many? 12. And yes, you can simplify it, but I'm just going to go ahead and do it this way because there are different ways to do it. 1 times 2 is 2. 12 times 12 is 144. And then you can simplify that to 170 seconds. Okay? So the probability of getting a purple and a green is going to be 170 seconds. Let me check my answer. Boom. Got it right. All right. Now here we got some more practice on your homework. We want to know what is the probability of tossing a head on a coin and getting a number less than 3 on a number cube. All right. So here you want to write down the probabilities. So you want to figure out what's the probability of getting a head and then getting a number that is less than 3. Okay. So we got to figure out the individual probabilities. And again, these are independent. So the tossing of the coin does not affect the tossing of the die. So what's the probability of getting a head? Well, on a coin, how many desired outcomes of head are there? 1. How many total outcomes are there? There are 2 heads and tails. All right, on a die. Well, on a die, you remember you got 1, 2, 3, 4, 5, and 6. How many of those are less than 3? Well, 1 is less than 3. 2 is less than 3. Is 3 less than 3? Nope. And so there's how many values are less than 3? Well, we just got 2. 1 and 2. How many total outcomes are there? Well, there's 6 numbers. 6, and yes, that simplifies to 1/3. But I'm just going to leave it that way because you can see that the 2's cancel out. Let me use a different color. Let's use red. The 2's cancel out. And so you end up with a probability of 1/6 of that, of getting a head and getting a number that is less than 3. Okay, and there you go. 1/2 times 1/3 is 1/6. All right, here we got 2 more events. We want to know what is the probability of spinning a 3 and then getting a vowel, and they tell you to use the spinners down below. So you want to write it like this all the time in probability format. What's the probability of getting a 3 and getting a vowel? All right, so let's figure out the probability of getting a 3. Well, this is the first spinner. Probability of getting a 3. How many desired outcomes of 3 are there? There's 1. How many total outcomes are there? 1, 2, 3, 4. Okay. Vowel. How many desired outcomes of vowel are there? Well, is A a vowel? No. Is B, A is a vowel. Is B a vowel? No. Is D a vowel? No. C is a vowel? No. Remember, the vowels are A, E, I, O, and U. And so how many vowels are there? 1. Out of how many outcomes? 4. And then you just multiply them. You figured out the probability of each one, and then you multiply. 1 times 1 is 1. 4 times 4 is 16. And so the probability of getting a 3 and a vowel on these spinners is 1/16. Okay, there you go. Boom. Got the correct answer. And then the last one on your homework. What is the probability of spinning an odd number and then spinning a consonant? Again, you want to write it in probability format. So what's the probability of getting an odd number and then spinning a consonant? Okay. And yes, we have 2 different spinners. So what's the probability of getting odd on the first spinner? So how many desired outcomes of odd are there? Well, 1 is odd, 2 is even, 4 is even, and 3 is odd. So we got 2 desired outcomes of odd. How many total outcomes are there? Well, there's 1, 2, 3, 4 total. And so the probability of getting odd is 2 out of 4, which we can simplify to 1/2. Consonant, Well, what's the probability of getting a consonant on the second spinner? Well, we already remember that A is a vowel, so that's not a consonant, which is the desired outcome. But we got B, C, and D. Those are all consonants. So we got 3 desired outcomes of consonants. How many total outcomes are there? Well, there's 4 because there's A, there's B, there's C, there's D. So there's 4 total outcomes. And so now to figure out the probability of getting an odd and a constant, you multiply. Now, yes, you can cross cancel. So I can see that the 2, whoops, let me use a different color. Let's use blue. The 2 goes into 4 2 times. And then you just multiply across. And I'll do it here on the side. We end up with 3 eighths because 1 times 3 is 3. And 4 times 2 is 8. And then you cannot simplify it. So the probability of getting an odd and a constant on those specific spinners is 3/8. Okay, and I hope this helped you out. Well, let's verify my answer first. Yes. Okay, hope this helped you out. Try today's homework. Have a good day.